Hi everyone, it's Coach Fred here, and I'm going to be going over another example of the vertical motion problems as they relate to quadratics. And so we're going to talk about the vertical motion models just as a recap. We've been investigating these in class. We know where they come from. We know they include gravity. And we know now that the flight path of an object thrown in the air can be modeled by a quadratic function, and that should kind of make sense to you. If I'm standing somewhere like right here and I throw a ball up in the air, it's going to go up and it's going to come down. You could kick a soccer ball, a basketball, a baseball, but they're going to follow that basic path. Now, we have two models. These are models, which mean they're formulas that we plug information into. The negative 16 and the negative 4.9 are going to stay because that's the part of the model that includes the gravitational force. And we talked about where that came from. But then we're going to plug in V sub 0 and H sub 0. As a reminder, V sub 0 is your initial velocity of the ball or whatever you're throwing, and H sub 0 is the initial height, or the y-intercept if you really want to get technical. All right, now why are there two models? Well, because one of them is in feet per second, the first one's in feet per second, and the second model is in meters per second. Okay, and again, we talked about that in class, but these models are used quite frequently, so it's really helpful to know them. Today, we're going to talk about, we're going to be using the feet per second model. We'll probably use that a lot right now, okay? All right, so let's look at our example. Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t equals, there's that negative 16t squared, plus 16t plus 480, where t is the time in seconds and h is the height in feet. So now, one thing that I think is really important to do on these questions is to really quickly make a sketch of what's happening. Now, we want to remember that the x-axis represents time, so it's like the time axis, and the y-axis represents height, okay? So if I draw this, I'm starting up at 480 feet because I'm on the cliff. I'm going up into the air and then I'm coming down like that. So that's an example of what I'm looking, what's happening. But because that's going to help me figure out what are they asking me for. Okay, so it says, how long did it take for Jason to reach his maximum height? Now that maximum height means I want the vertex, but the vertex right here is a coordinate, so it has two components. It has a time and a height. So because it says how long, I'm looking for the x coordinate of the vertex. And since this is in standard form, I'm going to do x equals negative b over 2a. But we're not using x, it's really t. So it's t equals negative b over 2a. All right, so our b is 16. Our a is negative 16. I'm going to plug those right in. All right, so negative 16 all over 2 times negative 16 gives me, 1/2, because it's negative 16 over negative 32, so 1/2 of a second. Okay, so how long did it take? It took a half a second for me to get up to my max height. What was the highest point that Jason reached? Okay, so that's asking me for the height, the maximum height, which is the y-coordinate of the vertex. So we plug in our x to find our y. So in this case, we find h at 1/2. So that's going to be negative 16 times 1/2 squared. Actually, let me switch to a thinner pen. Plus 16 times 1/2 plus 480. Okay. All right. So I've got negative 16 times 1/4 plus 8 plus 48. Negative 16 times 1/4 is 4. So that gives me negative 4 plus 8 plus 48, which is 4 plus 48. I'm sorry, plus 480. Hopefully you caught me there, plus 480. So that's going to give me 484. So my answer is going to be 484 feet. That's going to be the maximum height. So I didn't really go up that much, another 4 feet, but that sounds about right, doesn't it? All right, and the last question they ask is, Jason hit the water after how many seconds? So let's go back to that picture. He hit the water right here. That's the x-intercept. or when h is equal to 0. So we're going to set h at t equal to 0 and solve. So negative 16t squared plus 16t plus 480 equals 0. All right, I always like to try and factor if I can first, but I don't like to factor if there's a negative in front of the a term, if the a term is negative. So I noticed that all of these are divisible by 16, so I actually decided I was going to simplify the equation by dividing every term by a negative 16. Okay, all right, so that's going to give me t squared minus t minus 30 equals 0. Wow, I love this because you know what? I can see already that this is something I can factor. We always want to try to factor if we can first. And if we can't factor, we're going to jump to either the square root method, completing the square, or the quadratic formula to find those x-intercepts. But here I'm going to factor. So I can factor this into t minus 6 and t plus 5 equals 0. I can move to the zero product property and set each factor equal to 0. And so t equals 6 and t equals negative 5. Well, time can't be negative, so this answer gets thrown out. So after 6 seconds, Jason's going to hit the water. Now, I just want to point out that negative 5. If this were a real parabola that we graphed with no real-life example, the parabola would finish by going this way. So that other x-intercept over there is negative 5. It just doesn't mean anything in the context of this problem because it's not really in the domain of the problem. Domain or range of the problem. So anyways, hopefully that was a helpful video. Have a great day.